Good morning, students. In today's class, I will explain one basic concept of object oriented programming called objects and classes. The fundamental concept of any object oriented programming are objects and classes. The additional concepts such as encapsulation, polymorphism, inheritance, they are all considered as derived concept of object oriented programming because they are derived from the classes. Classes serves as a basic concept. In our last class, we discussed some program based on the concepts such as function overloading, default argument, inline function, call by value, and call by reference. As an example for function overloading, we studied the program on adding two number, finding the square root of a number, and determining the biggest among three number. As an example for default argument, we learned the program to compute the simple interest given principal, time, and rate of interest. For inline function, we discussed the program to check whether a given number is even or odd. The main objective of today's session is to introduce the basic concept, classes and object, and the differences between a structure in C language and class in C++. And we will also going to learn about how to define a class. At the end of today's class, you will be in a position to understand the basic concept of classes and object, in what way a structure and classes are different, at the same time in what way class structure and classes are similar, and how to define a class and how to create objects of the respective class. A class is a basic concept in an object oriented programming. It is considered as a self contained entity. And any class you take, it includes certain data and certain functions. The data declared inside a class are considered as member data. Similarly, the function defined inside a class are considered as member function. The member data can be accessed only by the member function. A class is nothing but an extension of structure of C. So the classes are nothing but an additional concept, or it's nothing but an improved version of a structure. So that's why it's considered as an extension of structures of C. And a class serves as a template for creating object. Class tells you what are the data and what are the function included in every object that is created out of that particular class. For example, if student is a class and S1 and S2 are the two objects of the student class, means the member data and member function defined inside a student class is there both in S1 and S2. Here, student is considered as a class, S1 and S2 are considered as objects. Next, a class is similar to data type in C language, and objects are similar to variables of programming language. For example, int a comma b. Here, int is a data type, a and b are the variable. In C++, equivalent to that one, in the place of data type, we have a class. In the place of variable name, we have object. Every object belongs to one particular class. For example, if student is a class, then Anita, Sunita, Rakshit, they're all examples of student mean. They are all considered as object. All these three objects belongs to a class called student. Let us see what are the differences between a structure and a class, and what are the similarity between a structure and a class. A class is similar to structure in the sense, inside the structure, you declare certain data. The data declared inside a structure are considered as structure members. All the members of a structure may be of different data type. That means a structure include members which are of heterogeneous type. A structure is different from an array in the sense all the elements of an array are of homogeneous type, whereas a structure member are of heterogeneous type. Similarly, the member data of a class also need not be of any particular same data type. They may be also of heterogeneous type. This is the similarity between a structure and a class. But a structure is different from a class. That means, in other words, a class is different from a structure in two different ways. One is A structure do not permit data hiding. That means if you declare some member data inside a structure, there even though you have declared the data inside a particular structure, the members of a structure can be accessed anywhere in the program. That means all the members of a structure are by default public in nature. You can access any member of a structure through the structure variable anywhere in the program. Whereas the data declared inside a class cannot be accessed anywhere in the program. They are accessible only within that class. In other words, all the members of a class by default are private in nature. They are accessible only for that particular class. You cannot access them outside the class. Whereas structure member, you can access it outside the structure also through structure variable name dot member name. That means this is a major difference between a structure and a class. The member structure members by default are public in nature. The class members by default are private in nature. The second difference between a structure and a class is, in order to understand this one, you take one simple example. Let us declare a class structure called complex. Struct complex, open the brace, float real comma image. In that case, your structure name is complex and the members of a structure are float, image, real and imaginary. Later, inside the main program, you declare three structure variable struct complex C1, C2, C3. Now what happens is complex is class structure name, C1, C2, C3 are structure variable. Later what happens is you cannot directly write C3 equal to C1 plus C2. Means the plus operator cannot be directly applied on two structure variable. Instead of this one, if you have the variable like int a comma b comma c, then we can write c equal to a plus b. But here what happens is C1, C2, C3, they are not the variables of basic data type. They are the variables of structure data type. Means C never permits you to handle a structure variable in the same way as a basic type variable. But in C++, what happens is class variable can be handled in the same way as you are handling basic type variable. Class variables are nothing but objects. So in the same example, if you instead of declare them as a struct student, a struct complex, if I declare them as class complex, in that case, if C1, C2, C3 are the three objects of complex type, means straight away I can write it as C3 equal to C1 plus C2. The compiler never differentiate whether C1, C2, C3 are ordinary basic type variable or C1, C2, C3 are class type variables or object variables. So they are treated in the similar fashion. So this is not permitted in case of structure. So these are the two differences between a structure and a class. The members of a structure are public in nature. Members of a class are private in nature by default. And second one is structure variable cannot be treated as basic type variable, whereas class variable can be treated the similar way as we are treating basic type variable. Let us take some examples of class and some and object and what are the member data and the member functions of that particular class. First one is student. Here the class name is student and the examples of the student are Anusha, Kiran, Robert. So Anusha is one object, Kiran is one object, Robert is one object. Now, once you say something as a class, you should identify what are the member data of that particular class and what are the member functions of that particular class. The members data are name, register number, M1, M2, M3. That is marks in three subjects. The member functions are calculating total using M1, M2, M3 and grading them. So this class student has 5 member data and 2 member functions. Let us take the second example, book. And the examples of books are programming with C++, operating system, Java programming. So these three are the objects of book class. The member data of a book are title of the book, author, name, price, publisher. And the member function are listing the books based on the author or listing the books based on the publisher, listing the books based on the title, etc. Deleting a book, adding a new book. So these are the member function. The third one is stack. Stack you already studied in your second semester data structure. And S1 and S2 are the two stack variable. And the member data of a stack data structure is top, max, item, and the member functions are push and pop. The next one is furniture. So class name is furniture. The examples of furniture are table, desk, chair, etc. They are considered as object. And the member data of any furniture is color of the furniture, price of the furniture, and the dimension. And the member functions are area of the furniture and the volume. So these are the some 4 different examples of classes corresponding objects of the classes. And we also discussed about the member data and the member function included in each object. Now we will study how you should define a class. In order to define a class, the general syntax is class, you should specify a name to the class. For example, class student. Then there are 2 lines, private private member, public member. That means any members of a class, member means both data and function. Data and function can be declared under the line private or can be declared under the heading public. In the subsequent slide, I will explain what do you mean by private private members and what do you mean by public members. So any member, I told you now. So private private member. Member need not be only data. It could be either data and function. So you can have some member data and some member function under private column and some member data and some member function under public access. And later close the flower bracket and give the list of all the objects of that particular class. Anyway, this will be clear when we take some simple example. So here, while declaring, there is the object list of objects of that particular class. That is not compulsory. Later, you can anywhere in the main program also we can declare the object. So while declaring a structure, object list is optional. Only the member function have the access to private data member. That is the main advantage of C++. The member data of any class are private in nature means they are accessible only by the member function. The concept of putting member data and the member function together inside a class, we call it as encapsulation. It's also called as information hiding. Next, in the previous slide, we discussed about private and public. What happens when you declare the members as private? What happens when you declare the members as public? If any member is declared as a private means that member is accessible only within the class. You cannot access the private member outside the class. But if you declare the members as public, you can access it both inside the class as well as outside the class also. So in the program, depending on your application, which member you want to give the accessibility to access within the class, you make it as private. But some member, I want to access it outside the class also. Such member, you make it as public. Let us consider one simple example. Class rectangle. Here your class name is rectangle. Private. There are 3 member data called length, breadth, area. All of them are integer type. I declared under the access private. So that means length, breadth, area, you can use it only within the class. You cannot carry them outside the class. Next, I'll start with the public. First function is, so anyway, any class includes both data and function. First class is void read function. So that function is not accepting any argument and there is no return type. Hence, void read. The purpose of read function is to input the value for length and breadth. See out, enter the length and breadth, see in length and breadth. Second function, void calculate. That function also is not accepting any argument and not returning any value. So there you can calculate the value for the third member, area equal to length into breadth. The third function is void display and see out, area of the rectangle equal to the value of the area. So after that, you close the class. And after closing the class, you have to end the class with a semicolon. So in this example, I have defined a class called rectangle with how many member data? 3 member data. All the 3 member data, you declare them under the access private. And this class has 3 member function, read function, calculate function, display function. The purpose of read function is to input the value for length and breadth. Purpose of calculate function is to calculate the area of the rectangle. And the purpose of display function is to display the area. So generally, in all the C++ program, we declare member data under the private and member function under the public, because member function generally I will use it outside the class also, but data I will never use it outside the class. That is the main intention of objects and classes. You are not supposed to permit the data to move outside the class. That's the reason object oriented programming gives more importance to data rather than the function. So all our remaining discussions on objects and classes, data you declare under the access private, functions you declare them under the heading under the access public. Next, once the class has been defined, how to create object. So the general syntax of creating object is class name. First you specify the class name, for example, rectangle. Then you declare any number of objects, R1, R2, R3, etc. So here R1 and R2 are the object and rectangle is the class name. For example, void main. So generally objects are created generally inside the main function, but immediately after the class declaration also you can declare the object. Void main rectangle R1 comma R2. So rectangle is the class name, R1 and R2 are the objects of rectangle. So in our next class, I will take some more examples on objects and classes through certain program. So in the examination, the questions could be on the today's class could be explain the concept of objects and class with suitable example, distinguish structure and a class, illustrate how do you define a class and create objects in C++ with an example. You can give the same example. Dash is a template for creating object. In order to create object, first you should have a template or a structure. The structure we call it as a class. The correct answer is A. Members of a class are dash by default. All the members of a class by default, they're always private. So B. Objects in C++ are equivalent to dash in C. Data type is equal to class. Objects are equal to variables. The correct answer is C. A class is a container of any class you take. It includes two parts, data and function. Data are considered the member data. Functions are considered a member function. Data are declared with the access specifier private. Functions are defined under the access specifier public. So a class is a container of both data and function. The correct answer is D. Class takes memory. No, only objects take memory. The correct answer is B, false. So in today's class, I introduced the concept of classes and object, and also discussed about how a class is similar and different from a structure, how a class can be viewed as an extension of structure, what are the difference among these two, and with an example, I illustrated how to define a class, how to create object. In order to define a class, first you give the class name, class name, open the bracket, then you make two parts, private part and public part. Under the private colon, you declare the variables one by one. The variable declared inside the private, inside the class, we consider as a member data. Then under the public access specifier, you declare the function one by one. Then after defining all the function, you close the class by putting a semicolon. There only you can declare the object, or you can declare the object inside the main function also. That's why object list is not compulsory at the time of defining a class itself. So with this, I will conclude today's class. Thank you.